Number 25 is a problem with vertical velocity, and on the test you will be given this formula. Okay, what you want to do when you see this formula is the first thing you need to do, it's super important, is you need to find the initial velocity and the initial height. Fill those two things in first, always. That's what A is asking for, but on the test it might not ask you for that. You should do it anyway. So the height of the ball can be modeled by negative 16t squared plus the initial velocity of 50 feet per second times the initial height. Well, a ball was thrown upwards with an initial velocity. It did not tell us where the ball was thrown. So most likely the ball would be thrown from maybe 3 feet, 4 feet, 5 feet, 6 feet high. In this case, it didn't tell us, so we're going to assume it's 0. I won't do that to you on a test. Okay, I'll give you that height for sure. Okay. What this is, if you were to change this to a y equals negative 16x squared plus 50x, I don't really need the 0, right? You should always come up with this model before you read anything else about the problem. You just fill in your v and your h. Okay? This would look like a graph. It'd look like a quadratic, right? Something, I don't know exactly what it would look like, but I know they're going to throw the ball up and it's going to come back down. So when they ask for the maximum height of a ball, they're looking for this, which we know is the vertex. And we have a formula for the vertex. The formula for the vertex is x equals negative b over 2a. Well, that's negative 50 over negative 32, which equals about 1.5625. Well, that means that's how long it took, right? X is seconds, so this is really time here. Right? My time, it's how many seconds it takes to get to the maximum height. To find the actual height, I have to plug that in. 625 squared plus 50, 1.5625. Again, where did I plug that in? I'm plugging it into my original equation that I had. That's why it's super important to write the equation before you actually try to solve anything. So I'm going to type this into my, and I get 39.0625 feet. That's the maximum height. Okay, the question C, how long does it take? Well, we actually answered that right here. It took 1.5625 seconds to reach that height. And then D says, when does the ball hit the ground? Well, what are they telling me? When they're asking me for T hits the ground, they gave me an H. Specifically, they gave me an H value of 0. Right? When it hits the ground, the height is 0. So what I'm going to do is I'm still using this original equation the whole time. Only now my H is 0. And you can solve this a couple ways. You can solve this by quadratic formula, or you can solve it by factoring. Factoring works because there's a GCF, but I'm going to go ahead and do it by quadratic formula. So my A is negative 16. My B is 50, and I don't have a C, so I have to use the 0. X equals, or T equals, doesn't matter which letter you use, opposite of B, plus or minus square root of B squared. I always like to do the B squared. 2,500 minus 4 times A times C, all over 2 times A, which is negative 32. Go and type that in your calculator and get both your answers. So I got 2 answers for my T. I got 0 and 3.125. The question is, when does the ball hit the ground? Well, does it hit the ground in 0 seconds or 3.125 seconds? Yeah, 3.125 seconds would be the more reasonable answer there.